In this video, we'll introduce virtual volumes. Virtual volumes is really the next generation of vSphere storage. And we've already spent some time learning about VMFS data stores and NFS data stores and things like that, and virtual SAM. Virtual volumes are kind of the next step in the evolution of storage. But the other nice thing about them is they support a lot of the existing storage architecture that already exists. So, for example, virtual volumes support common storage networks like Fiber Channel and iSCSI and NFS. But the biggest difference is that our virtual machine objects are actually exposed to the storage array, right? So let's kind of think about the way that things are right now, right? Without virtual volumes, what we've got are data stores, right? We've got these data stores, and here's our data store, and our data store is formatted with VMFS, right? So here's a VMFS data store, right? Well, when you take a data store and you format it with VMFS, you're creating a file system on that data store that the storage array does not understand. Right? The storage array is not able to dig inside of a VMFS data store and view individual virtual machine objects. Right? And that's the biggest difference between virtual volumes and the traditional LUN and VMFS architecture, is that we can manage individual virtual machine objects at the storage array level. This makes things like cloning and snapshots very different than they've traditionally been with a VMFS data store. So with a traditional data store architecture, what we have are logical unit numbers. We're going to have these LUNs, and on those LUNs, we're going to create VMFS data stores. So here we see two LUNs, and on each LUN we've created a data store, and then we can store all of our virtual machine objects within those data stores. And what the LUN has typically provided is basically a container where all of those virtual machine files will be hid. Rephrase. And what the LUN has typically provided is a storage container where all of those virtual machine files will be located. Now, with VVOLS, the concept of a LUN and data store go away. So with VVOLS, what we're going to do is we're going to have a new object called a storage container. And all of our VVOLS, our virtual volumes, are going to be stored in this storage container, and the storage container doesn't have the traditional limitations of a LUN. Right? The only restriction is the maximum actual physical storage capacity of the array. So do data stores still exist? Well, technically, yes, they do. But data store is purely there for functions like high availability data stores and things like that. What really is going on now is we've got this one big storage container on the storage array. And the storage array has visibility to all of the individual virtual machine objects that are contained within that storage container. So our storage container is where all of our virtual volumes exist. Right? And as a virtual machine needs to send storage commands to its virtual disks, for example, we have something called the protocol endpoint that basically handles all the traffic. Right? So our host doesn't really care about the storage container. It doesn't care how big or small it is. It doesn't care how many of them there are. Right? There's going to simply be this protocol endpoint that will serve as an interface to the storage container. And so when my virtual machine issues a SCSI command, the SCSI command, just like always, will flow out of the virtual SCSI controller of the VM, and the ESXi host, the hypervisor, will send it to the appropriate storage adapter through the protocol endpoint, and the data will be written to that individual virtual volume. So that's kind of some of the underlying mechanisms that are involved with virtual volumes. Now, from the perspective of what benefits does it provide? Let's say that you need to clone a virtual machine. right? So we have this virtual machine, and the VVOL for the virtual machine is here. And we need to clone it. Well, rather than handling the cloning operation at the ESXi host level, we can handle it at the storage container level and at the storage array, because the storage array can see all of these individual VVOLs, and that's much more efficient. Right? Let's think about a cloning operation where the host is handling it. Well, what's going to happen in that scenario is all of this virtual machine's data is going to have to get pulled into the host, and then a copy of it has to all get pushed back to the storage array. Right? That's the way that cloning has traditionally been performed. What if instead of this traditional method, if we wanted to perform a cloning operation, maybe vCenter could simply send a command to the storage array and tell the storage array, hey, this virtual volume needs to be cloned. This virtual volume needs to be snapshotted. Right? And then the storage array itself handles that workload without having to transmit all of that data over the storage network, right? We don't need that. We can offload those tasks to the storage array. So there are huge efficiencies with virtual volumes, and that's why it's kind of the push towards the next generation of storage. Now, these are not going to displace traditional VMFS data stores anytime within the next couple years, but eventually the percentage of virtual volumes backed storage devices will continue to grow.